Welcome to solverfy.
Hi there. So for this problem, we are told that in quantum theory, a certain method um, gives the amplitude for the scattering of a particle of mass m through an angle theta by an uniform potential well of depth b sub 0 and radius b, as the following expression that is shown in here, where h bar is the Planck constant divided by 2 times pi, and the energy of the particle is h bar squared times k squared divided by 2 times m. And k in this case is equal to 2 times k times the sine of pi divided by 2. So we are told to use L'Hopital's rule to evaluate the amplitude at low energies. When k, and hence capital K, tend to 0, and so we need to determine the low energy total cross section. So in this case, we're told that we need to use L'Hopital. So we need to determine the value of the following, what we are going to call ELT, and that is the limit when k tends to 0 of this expression right here divided by this. So we will have that this is sine of capital K times B minus capital K times B cosine of capital K times B, and all of this divided by capital K to the 3. Now what we are going to use is the series for the sine and cosine function. So with that, we're going to have something of the form k times b minus k times b to the 3 divided by 3 factorial plus this minus k times b times 1 minus k times b to the square, and this divided by 2 factorial plus k times b to the 4 divided by 4 factorial minus dot dot dot. So all of this divided by k to the 3. Now in here we can simplify these expressions, and we will obtain that this is equal to the following. Is capital K times b to the 3, and this times minus 1 over 3 factorial plus 1 over 2 factorial plus elements that has an order. There are going to be k to the square times b to the square, and this divided by k to the 3. So from this, when we do the limit in here, we will obtain that this is equal to 1 over 3 times b to the 3. Thus, the function that we are given can be written out as 2 times the mass m times the potential b sub 0 times b to the 3 divided by 3 times h bar to the square. This result is real and independent of theta, so indicating that the scattering is isotropic. Consequently, the total cross-section is simply equals to 4 times pi times the square of this function that we have in here. So if we do that, we obtain that the cross-section explicitly, cross-section is equal to 4 times pi times 2m times b sub 0 times b to the 3 divided by 3 times h bar to the square, and all of this to the square. So that's the solution for this problem.